It won't take us long to finish this example. We're to the point where we need to check the endpoints. So let's do that. For x equal -3, we're going to wind up with k equals 0 to infinity, -1 to the k, -3 to the k, plugging -3 in for x, 3 to the k times k plus 1. So let's take some time to clean that up. We have k equals 0 to infinity. And now we're going to have -1 to the k times -1 to the k times 3 to the k. And all I've done is take this term and pull the -1 out, the -1 to the k out. And I've done that because I see clearly that those are going to cancel. So when I multiply the same bases, I'll take some time to rewrite this so you can see what I'm doing. When I multiply the same bases, and both of these have -1 as the base, I get to add the exponents. So that's what this looks like. So anytime, let's see, anytime we have any k value, when k is 1 it's even, when k is 2 it's even, when k is 3 it's even, when k is 4 it's even, 5 it's even, 6 it's, so the multiplying times 2 is literally making this a positive series. So this is acting like 1 over k plus 1. And this is identical to the problem that we did before. So if I call a sub k 1 over k plus 1 and b sub k 1 over k, then at k equals 0 to infinity, 1 over k is the harmonic series. And that diverges. And then we can put those into the limit as k approaches infinity of a sub k over b sub k. I'm running the limit comparison test. So this diverges by the limit comparison test. Now we'll come back over and we'll plug in x equal 3. We'll do that in a different color. So for x equal 3, we have the infinite series, and the first step is always just to plug in that value for x, which is what I'm doing right there. And those are going to cancel, so this series cleans up quite nicely to the alternating series that looks like that. So we can quickly run the alternating series test. We plug the positive portion in. If we get 0 out, this converges by the alternating series test. And again, we haven't answered the question, so we'll need to be careful here because the convergence set is, now this is the case where -3 was not included because it diverges when x is -3, but +3 is included because it converges. at positive 3. So you can see the work, when you actually plug those x values in, is probably likely to get pretty repetitive. You'll be seeing a lot of the same kind of work. You're not always going to run the limit comparison test or always have an alternating series. You may wind up where both of them are positive series. But you get the idea that you need to pick a good test that we learned on all those general series. And that's how you're going to find whether your endpoints converge, and that's going to allow you to find your convergence set, also known as the interval of convergence. So this is important. Make sure you understand all the pieces and parts of this, and come to class next time. We'll have a lot of homework practice to do on these concepts.